Hello guys, how's everyone doing? Let's see here. Let's go on to 8.1 and talk about that a little bit. We are talking about right here just basic confidence intervals, more the concept of it in this section right here. All right, concept one, when our goal is to estimate a population parameter, we often must rely on a sample statistic to provide a point estimate. However, as we learned in the last chapter, the estimate will vary from sample to sample. A confidence interval takes the variation into account to provide an interval of plausible values based on the statistic for the true parameter. All confidence intervals have two main components: an interval based on the estimate that includes a margin of error and a confidence level C that reports the success rate of the method used to construct the interval in capturing the parameter in repeated constructions. That's a little bit confusing right there. But basically they're saying that confidence intervals have two main components, right? They have basically your interval that's based on your estimate that includes the margin of error. All right, so you got your actual interval, and then you have something like a confidence level where it's a 90%, 95%. Usually it's around one of those two. Sometimes it's lower though. All right, and that's C that reports the success rate of the method used to construct the interval in capturing the parameter in repeated construction. So in repeated samples, like it's that percent of samples actually capture the true parameter. For example, C% confident means C% of all samples of the same size from the population of interest would yield an interval that captures the true parameter. We can then interpret the interval itself by saying we are C% confident that the interval from A to B captures the true value of the population parameter. All right, so let's do a couple of these. How much do the volumes of bottles of water vary? So we're right here right now, all right? How much do the volumes of bottles of water vary? A random sample of 50 20-ounce water bottles is collected and the contents are measured. A 90% confidence interval for the population mean mu is 19.10 to 20.74. First question is asked. Interpret the confidence interval, not the level, the actual interval. So remember, this always starts out, they just actually said when you're interpreting a confidence interval, you start out with we are C% confident right here. And in this case, we have 90%. So we start this out as we are 90% confident that the interval from A to B, in this case, A to B is 19.10 to 20.74, captures the true right here. And in this case, we're talking about the true population mean of volumes of bottles of water, right? Or you could say volume of bottles of 20-ounce water. Okay, so let's see how I wrote this right here. We are 90% confident that the interval from 19.10 to 20.74 captures mu equals the true mean volume in ounces of, quote, 20-ounce, unquote, water bottles. Okay, so right here, so in the context is right here, the parameter in context is mu, which is the true mean volume, and make sure you put the unit, which is ounces, of, quote, 20-ounce water bottles. So they're basically saying that in 20-ounce water bottles, it's, it's not always necessarily 20 ounces, all right? It's a little bit lower, a little bit higher, okay? 2, interpret the confidence level. Confidence level is a little harder, so let's relook. We just said right here, C% confident right here, and I have a different way of showing this, but this says that in C% of all samples of the same size from that population of interest, you would yield an interval that captures the true parameter. You would yield intervals, actually, that capture the true parameter. So let's take a look right here. If we collect many random samples of 50 20-ounce water bottles, okay, so I started that out. Let me actually, without showing it, let me just talk about that for a second. So if we collect many, started out with always, if we collect many random samples of whatever we're collecting, right? And then we're going to say, we're going to use that confidence level. We're going to say, in this case, we're talking about 90%. About 90% of these samples would yield intervals that capture the true, and in this case, we're talking about population mean of 20-ounce bottles of water. So let's look. If we collect many random samples of 50 20-ounce water bottles, about 90% of them will result in intervals capturing the true mean volume of 20-ounce water bottles. Okay, so something about like that. I think this is like a really simple way of putting it. I remember when we did this activity, right? We had all these random samples. Most of them hit, but there were some that did not hit. These are all confidence intervals right here. So we said that about 90% of these intervals capture the true proportion. That's that thing that it's hitting right there. So that's saying we collect many random samples of these 50 samples of 50 20-ounce water bottles. About 90% of them will result in intervals that capture the true mean volume of 20-ounce water bottles. All right. Number 3, based on this interval, what can you say about the contents of the bottles in the sample? What can you say about the contents of the bottles in the population? All right, this is admittedly not a very good question. It's a bit confusing. They're basically trying to say, though, is, you know how they ask at the very end, a lot of these open-endeds, is there significant evidence right here? Do we have, is there, I should say better, is there convincing evidence that the stated mean is wrong? Okay, so that's kind of what they're saying right here. So based on what we have right here, can we say there's convincing evidence that this mean of 20 ounces is wrong? Well, I don't think we can, because know what? Looks like our confidence interval goes from 19.10 to 20.74. Guess what's in between there? Between 19.10 and 20.74 happens to be 20. Is right in the middle there. So that is in our confidence interval. So since 20 is within our confidence interval, we cannot say we have convincing evidence that the stated mean is wrong. So that's what I said. The stated population mean is 20 ounces, which is in the confidence interval from 19.10 to 20.74. There is not convincing evidence that the population mean does not equal 20 ounces. Okay? A little bit of a confusing question, but that's what they were asking. All right, let's look at concept 2 right here. Let's go change this color right here. All right, so let's take a look right here. All right, actually, let's do light green. There we go. All right, we will learn in the next section that to construct a confidence interval, we must work through several steps. First, you must check the conditions for constructing the intervals are met. That is, we must be assured that the data come from a random sample or a randomized experiment. A random sample or else an experiment that the treatments are randomized. Okay, so one or the other. Next, the sampling distribution of the statistic must be approximately normal. Finally, the individual observations must be independent, which means checking the 10% condition if we're sampling without replacement from a finite population. So they mentioned 3 things right here. You have basically what you have is you have random, you have 10% rule, and you have what we call large counts, right? Large counts, remember, shows that that we can use a, we can find the z-score correctly, if you recall right here. So in this case, the sampling distribution of the statistic must be approximately normal, right? So therefore, if it is approximately normal, we can appropriately find z-star in the formula. 10% just shows that we're working with independent samples right here. And random, of course, just means that we have found this at least from a random sample or random experiment. All right, so we construct the interval using this formula: statistic plus or minus critical value times the standard deviation of the statistic, where the critical value is determined based on the confidence level C and the standard deviation is based on the sampling distribution of the statistic. We interpret the interval using language we learned earlier in section. Our goal with the confidence interval is to provide as precise an estimate as possible. That is, we wish to construct a narrow interval that we're confident captures the true parameter of interest. We can achieve this in 2 ways: by decreasing our confidence or increasing our sample size. So this basically, all right, maybe a little long-winded right there, but basically what they're saying is if we are trying to construct a narrow interval, we can do this in 2 ways. All right, if we lower our confidence level, so we lower the confidence level, what's going to happen right here is that the interval, if it's long, will actually shorten up. Also, if we increase our sample size, so right here, if we have a sample size of 20 and we increase it to sample size of 100, that is going to actually decrease the size of our interval. So, all right, that will actually decrease the size of interval if we raise the sample size. Okay. So, and you can always remember this, by the way, if you raise the sample size, the standard deviation decreases, which causes you to have a smaller margin of error, smaller interval. All right, let's take a look here. A large company is interested in developing a new bakeware products for consumers. In an effort to determine baking habits of adult, researchers selects a random sample of 50 addresses in a large Midwestern metropolitan area. She calls each selected home in the late morning to collect information on their baking habits. The proportion of adults who bake at least twice a week is calculated and a 95% confidence interval is constructed. Okay, explain what would happen to the width of the interval if the confidence level were decreased to 90%. So what they're saying basically is that we have a confidence level of 95%, but we're going down to 90%. All right, so what would happen right here if we decrease, if we're less confident? So just think right here, if we're less, So just think right here, guys, if we're less confident, we don't have to have such a long interval. If we have less confidence, then we can actually decrease the size of our interval because we're not as sure. So we can go and decrease it. All right, it can be smaller. All right, we don't have to overcompensate. So when decreasing a confidence level, the margin of error decreases. Therefore, the confidence interval narrows. Okay. 2. How would a 95% confidence interval based on a sample size of 100 compare to the original 95% confidence interval? Well, the original 95% confidence interval had 50, n equals 50 right here, people that they called up. All right, so from n equals 100 to n equals 50, what would happen? Remember right here what I just said before. If we right here are increasing the sample size, the interval will narrow because that's going to decrease my standard deviation. So I'm going to say when increasing the sample size and keeping the same confidence level, the margin of error decreases. Therefore, the confidence level is going to, oh, sorry, that's a mistake. The confidence interval right there. Let's fix that. My fault. Therefore, the confidence interval will narrow. Okay. So again, just to explain that, we have n equals 100. But originally we had n equals 50. So we got more people right here. That's going to lower my standard deviation. And remember, these intervals are made from standard deviation. So that means that my standard deviation will decrease, which means that my confidence interval will narrow, right? And so I said the standard deviation, that's how you get the margin of error actually, that decreases, and your confidence interval will narrow, okay? 3, describe one potential source of bias in the study that's not accounted for by the margin of error. So first of all, first thing I noticed is that they're asking people about their baking habits, right? And you would just have to have one example. I put 2 in here. You just need one, right? But they're at an effort right here. Research, they select 50 addresses, and they call each selected home in the late morning to collect information about their baking habits. All right, so I said right here that some participants may not be truthful about their baking habits and may inflate the number of times they bake in a week. I don't know, that's just a natural thing. Some people just, make what they do sound, more impressive. Secondly, it says also calling people in late morning would make the sample primarily people who do not work during the day. All right, so that's just, you're just getting a sample of, primarily one type of person. So the margin of error obviously does not account for either of these biases. All right, so you could have either one. You could have this first one. You could have the second one. There may be something else you could think of too about calling people in the late morning and why that would cause bias. All right, there's, many possibilities right here. Okay, so either one's okay. You don't have to have both right here. You just have to have one example. And just mention that the margin of error obviously does not account for this bias. All right, guys, that is it. Hope you guys are having a great vacation. Have a good day. See you later.